Actually revision. So how did you find the charge beta? Charge flowing through any conductor is been already calculated by charge q is equals to integral of current as a function of your time t into your dt with the limits of your t1 to your t2. Can I write like this?
Yes, sir.
Isn't it? Like say for example, I can write here current as a function of time t, and he may be giving you like 2 into your sine of your 100 pi t, something like that. Or current as a function of a time t, and he might be giving you t into your t cube, something like this. So if I give the current as a function of time, you can just integrate it. When proper limits you keep it, you will get the charge.
Yes, sir.
Isn't it? Sure. The next very important formula is how do you write your drift velocity? Drift velocity represented by Vd. Drift velocity is nothing but the velocity of electrons when a conductor is connected to your battery. Like say for example, this is your battery. There are electrons in this one. This is some conductor, and you are connecting it to some positive terminal and negative terminal. And due to positive and negative, this electron will be starting drifting in the backward direction. That drifting is called as drift velocity, and there is a flow of a current like this. Electronic current in the conductor is in the opposite direction. This is the conventional
Yes,
flow of current, and this is your actual flow of your current in the outward. Both of them are in the opposite direction, isn't it? So this drift velocity
yes,
is
sir.
given by the formula Vd is equals to your charge of electron, electric field into your relaxation time divided by your mass. This is your drift velocity. Vd is equals to charge of electron, electric field, E capital E is your electric field, T is your time of relaxation. What is your T beta? T is your relaxation time.
Yes, sir.
What do you mean by relaxation time? Average time between any two collisions. Because when they are
Yes,
moving,
sir.
these two electrons might be colliding kada. So time
Yes.
between this average time between any two electrons when they have been colliding is called as of your relaxation time. Clear?
Yes, sir.
And current is also been written as one more relation, that is Vina. I is equals to your Vina. And the drift velocity, charge of your electron, and your n. N is nothing but what beta? Number of free electrons per your unit volume. And A is your area of your cross section. So the current in terms of your drift velocity and area will be written as I is equals to Vina. I is equals to what? Vina. Vd is your drift velocity, E is your charge of electron. What is your n beta? N is nothing but number of free electrons. Number of your free electrons per unit volume. Then beta?
Yes, sir.
Sure. Very important formulas beta. As usual, go through it in the physical. Next one in this one more term you should remember, that is about your mobility. How do you define your mobility? Okay, mobility is your ratio of your drift velocity to the electric field applied. Capital E and N is electric field. Capital E is nothing but electric field.
Yes, sir.
Vd is your drift velocity, isn't it? So drift velocity already I know here right now. I can substitute that value here. E into capital E into relaxation time divided by your M into your E. This E will get cancelled. So it is E into relaxation time divided by your mass. I can even write like this. Okay.
Yes, sir.
Unit will be, can you tell me what will be the unit of this one, beta? Velocity is measured in meter per second. No, sorry, velocity is measured per year, meter per second, and electric field is measured in. How do you measure the electric field? Electric field is equals to V by D, kada?
Yes,
V is
sir.
measured in your volt, distance is measured in your meters. Voltmeter,
Yes, sir.
isn't it? Drift velocity is measured in your, velocity is your distance divided by time. That means it is meter per second. So what will be the unit? Divide meter per second divided by voltmeter. And remember,
मीटर का टाइप वोल्ट सेकंड पर मीटर स्क्वायर ना
ಏನಣ್ಣ
वोल्ट सेकंड पर मीटर स्क्वायर.
drift velocity is equals to distance by time. isn't it? So that means it is meter by second divided by electric field is equals to your volt divided by meter. And the meter will go up, so it is meter square volt second. అంతే కదా?
Yes, sir.
Can I write like this? Antena?
Yes, sir. Yes, sir.
Sure. Next one again important term, current electricity. That is nothing but of your current density. Very, very, very important term. Current density is your represented by share. Now tell me what is the current beta? Is it a vector quantity or scalar quantity? Current, even though it has both magnitude
It is scalar.
direction, but it doesn't obey the vector addition law. That is the reason it is a scalar.
Yes, sir.
Isn't it? Whereas if your current density, it is a vector quantity. It is a vector quantity. So I define the current density. Current density is your current per your unit area. Current density is nothing but what? Current density is your, sorry, J is equals to your I by your A. Or else I can write here current I is equals to your J bar dot your A bar. I is equals to your J bar dot A bar. J bar dot A bar. What will be the unit for this one, beta? Current is measured in ampere. Area is measured in meter square. So it is ampere meter square. Okay.
Yes, sir.
And electric field is also defined as E is equals to rho into J. What do you mean by rho, beta? Rho is known as resistivity. Rho is known as resistivity. Clear?
Yes, sir.
So current is nothing but what, beta? Current is your integral of your I into dt. Whereas drift velocity is nothing but for me what? Charge of electron into electric field into tau divided by your mass. Tau is known as relaxation time. Relaxation time is nothing but what, beta? Average time between any two collisions of an electrons during the motion. And current is also defined as of your V now. So this is your drift velocity, charge of electron, N is number of free electrons per unit volume, and A is area of cross section. Mobility is represented by mu. Mu is equals to ratio of drift velocity divided by electric field. Or else it is E by your M. E is charge of electron, tau is your relaxation time, M is your mass. Unit is meter square volt second. Okay. Next one is current density. Current density is represented by J. J is equals to current per unit area. Or else I is equals to J bar dot A bar. Or electric field E is equals to rho into J. Done, beta?
Yes, sir.
This one is your mobility. This is your drift velocity. Clear?
Yes, sir.
Next one. Resistance. Resistance of wire represented by letter R. Formula gurtundana, standard formula. R is equals to your M divided by your N into E square relaxation time into your L divided by your A. Okay. Unit for this one is ohm. Represented by symbol like this.
Yes,
Okay.
sir.
ఇది మొత్తం ఏదైతే ఉందో ఇది మొత్తం కాన్స్టెంట్ కదా. Mass of electron N E
Yes,
C
sir.
is
Yes,
right
sir.
now constant. This constant is called as of your rho. Okay. So resistance is represented by R is equals to rho into L divided by your A. Okay, na?
Resistivity.
Rho is known as what? Resistivity.
Yes, sir.
Rho is known as what? Resistivity. And sigma is known as 1 by rho. Reciprocal of resistivity is known as what, beta? Conductivity.
Yes, sir.
This sigma is known as of your conductivity. So I can say from this one, R is directly proportional to. So from this one, I can write some points. Like R is directly proportional to the length. R is inversely proportional to area of your cross section. One more point. If temperature increases, resistance what happened beta? Can you tell me? Increases.
Yes, sir.
Because in generally why it's gonna a huge amount of energy or current పోయిందనుకో వేడికి పోతుంది కదా, it will get burned also. So
Yes,
the
sir.
temperature is increasing, resistance of the wire is also increasing.
Increasing.
Clear?
Yes, sir.
See how is that possible? Like we know the resistivity formula, rho is equals to your what beta? M divided by your N into E square into your tau. Another. So if temperature increased, then what is happening to the relaxation time? Relaxation time will be decreasing. If the relaxation time is decreasing, resistivity will be increasing. If resistivity is increasing, resistance will also be increasing.
Yes,
Okay?
sir.
Sure. And this one very important formula. For small variations in temperature. So when temperature is been changing, how the resistance is been changing. Formula gurtunda? Resistance at some temperature T2 will be equal to your resistance at your T1 temperature into 1 plus alpha into your delta T. Where alpha is known as what beta? Coefficient of your temperature. Coefficient of your temperature. అదేవిధంగా resistivity రాసుకుంటే resistivity rho at your temperature T2 is equals to resistivity at a temperature T1 into 1 plus alpha into delta T. Delta T is temperature difference. Alpha is known as what beta? Temperature coefficient.
Yes,
Temperature
sir.
coefficient. Very important formula beta. Okay. ఇంకో పాయింట్ రాయండి. For semiconductors, Nana, very important. For semiconductors, ఒకవేళ temperature పెరిగితే, if temperature is increased, what is happening to the resistivity beta? Resistivity decreases. If resistivity is decreasing, resistance is also decreases.
Yes, sir.
Clear?
Yes, sir.
So very important relations. Small variation in the temperature is R is equals to R naught into 1 plus alpha into delta T and kuda pettukochu. Yeah, resistivity at your T2 temperature into resistivity at your T1 temperature into 1 plus alpha into delta T. Clear? And basic
Yes,
resistance
sir.
formula is R is equals to rho into your L and depends upon directly proportional to length, inversely proportional to area, and also depends on temperature. And sigma is equals to your 1 by your rho. Rho is of sigma is known as what? Conductivity. Clear?
Yes, sir.
Sure. Next one is about your graphs. As per NCRT beta, you might have even studied these graphs. These are very important graphs. You need to remember them. First one. If I'm drawing the graph between resistivity and your temperature, capital T. The graph is something like this. Clear?
Yes, sir.
In the same way, if I'm drawing the graph between your resistivity and as well as of your temperature also. This is for an element called as of your copper. Whereas for your element nichrome, if I'm drawing the temperature, it shows some peculiarity. Initially, there is no change, but after a certain interval of a time, the graph is something like this, a straight line.
Yes,
That
sir.
then resistivity and as well as of your temperature. For semiconductors. This is important graph beta. As per NCRT, the graph is rectangular hyperbola like this. Copper key parabolic in the upward direction. Nichrome, it is a straight line, but not starting from the origin. It is having some constant right now.
Yes, sir.
Currently, these are NCRT. You may directly give the graphs and I ask to identify which is a graph for nichrome, copper, or maybe semiconductors. You need to remember them.
Yes, sir.
Okay.
Yes, sir.
Even if I'm writing nichrome, yeah, it may be even for your manganese and a constant, something like this.
Yes, sir.
So all of this is filled with a graph. Okay, now?
Yes, sir.
Sure, next one. Color code guttunda nana? Very important.
Sorry, sir. Interview.
Color coding guttunda?
Yes, sir.
Sure. This is a color coding beta.
Yes,
Okay.
sir.
First two digit will always represents me right now. This is the first digit, second one is second digit, third digit, then last fourth one will represent the multiplier, then fifth one will represent the tolerance, and last one will represent the temperature coefficient.
Yes, sir.
Okay. First one here represents just on the first digit. Like say if it is like a black, for black, the first digit is nothing. Second digit is 0. Third digit is also 0. Multiplier is 1. Okay.
Yes, sir.
Like say brown, it is 1. Second digit is also 1. Third digit is also 1. Multiplier is how much? 10. And tolerance is how much? Plus or minus 1%.
Yes, sir.
Isn't like say for example, చాలా important nanu aduguta చాలా సార్లు. Like this is a color code he has given. He has given a diagram like this. And he has given me the color coding. First one is like say for example of your brown. Okay, here I'm taking some colors better. This is some color, first one. And next one also some color he has given for me. And next one is also some color. And next one is also some color. Okay. And naming I'm giving better. Like say first one, if I'm saying that it is brown. And next one is your black. And third one is your red. And this last one is your gold. Now brown key, this is a brown. Isn't it? So what will be the number given for the brown beta? For brown, the first one is first digit is right now 1. And it will be your 1.
Yes, sir.
Okay, black. Where is the black? Black second digit enter. 0.
Yes, sir.
Red. Where is red here right now? This one. Red third digit is what for me?
2.
2. So this will be your 2. Golden. Golden ke tolerance enter.
తెలియదు సార్.
గోల్డెన్ కి టాలరెన్స్ ఎంత ప్లస్ ఆర్ మైనస్
సార్
5%.
కొంచెం జూమ్ చేస్తారా దాంట్లో?
ఓకే ఓకేనా, ఇది ప్లస్ ఆర్ 5%. ఇప్పుడు మొత్తం రెసిస్టెన్స్ రాయాలంటే ఏం చేయాలన్న ఆర్ ఈజ్ ఈక్వల్స్ టు దిస్ విల్ బికమ్ ఫర్ మీ 10 into 10 to the power of 2. ఇది మల్టిప్లయర్ కదా, ఫర్ థర్డ్ విల్ రిప్రజెంట్స్ మీ వాట్ బెటర్ మల్టిప్లయర్.
ఎస్ సార్.
అవునా కదా.
ఎస్ సార్.
So it is 10 into your 10 power 2 plus or minus of your 5%. ఓకేనా.
ఎస్ సార్.
రఫ్గా రాస్తున్నాను చూడు. ఫస్ట్ కోడ్ ల కలర్, the next one is your number, and third one will be your multiplier, and next one is your tolerance. ఇది గుర్తుపెట్టుకోవాలి నాన్న, వాడు ఎగ్జామినేషన్ హాల్లో ఇవ్వడు.
Yes sir.
Isn't it? Like say for example, first color if I am taking, what is the first color beta? Black. Next color is brown. Next one is red, orange, yellow, green, blue, violet, gray, white, gold, silver. And if no color is given, then how do you take it out? This is the color range you need to remember. Okay?
Yes sir.
Now numbering ekkada nunchi ista chudu. If I start giving the numbering for this one, start with the black 0. Okay na?
Yes.
దాని తర్వాత 1 2 3 4 5 6 7 8 9. Then gold, silver, and this there is no numbering. Okay. The next one multiplier. In the multiplier, the first one is 10 power 0. The next one is 10 power 1. Next one is 10 power 2. Next one is 10 power 3. Next one is 10 power 4. Next one is 10 power 5. 10 power 6. 10 power 7. 10 power 8. 10 power 9. The next one is for the gold, the multiplier is 10 power minus 1. And for silver, the multiplier is 10 power minus 2. For no color, there is no multiplier. Okay, madam? And tolerance,
Yes,
for the tolerance, if I am taking, for the gold, the tolerance is your 5%. And for silver, it is your 10. When no color is given, you should take it as 20. Clear, beta?
Yes sir.
Then
Yes sir.
he'll be asking the questions based on this one, but you need to practice this one regularly. Okay?
Yes sir.
Sure. Next one. Cells. Electric cells. Okay. So in this one, we talk about EMF, internal resistance of your conductor. Okay. So this is a basic symbol of your cell. Okay. EMF and the E. Internal resistance is R. Okay, madam. This is a terminal A,
Yes,
and this
sir.
is your terminal B.
Yes sir.
Okay, now sure. See, I'm taking the two conditions for this one. Like, if this is a cell, and this is a terminal B, and this is your terminal A. And if the current is in this one coming out like this. Okay, madam. So potential across here A and B will be equal to your how much? potential across your A and B will be equal to your how much? If the current is coming from this positive terminal, this is a negative terminal, this is E, internal resistance R. So what will be the potential beta? Potential across your A and B. Potential across your A and B will be equal to your I minus internal resistance EMF E and as well as of your R. That means work is done by battery. Work done by battery. Got it? If the battery is something like this is a terminal B, this is your terminal A, positive terminal, negative terminal, internal resistance. And the current is flowing inward right now. That means it will be what? Work done on the battery. That means you are charging it. So potential across your A and B will be equal to your, how much better? E plus I into your R, or I plus E into R, anything. So I can say here we are doing work. So here it is, work is done on the battery. Work is done on the battery. Very important formula is good. Okay. So ikkada బయటికి వస్తుందంటే this will be called as of your discharging. అవునా కదా, కరెంట్ బయటికి వచ్చేస్తుంది. So it is called as what? Discharging of your cell. Now you are giving reverse. Current you are giving from positive to negative. That means it is getting charged. So this will be called as of your charging of cell. This is called as of what? Charging of cell. Discharging ki charging ki arrow mark గుర్తుపెట్టుకోవాలి మనం. If the arrow mark is coming out, this will be your discharging. If arrow mark is going inside, that will be equal to your charging. Clear?
Yes, sir.
Let me give you one example. Let's see. There is a resistance right now like this. And there is a battery connected for this one. And here the part of the resistance. This one is known as small r. This one is your E. And this one is your external resistance, capital R. And this is a terminal A. And this is your terminal B. And say current is going outward like this. Okay. Then tell me what will be the potential across A and B beta? Potential across A and B will be equal to. Is binding both kada? Charging or discharging?
Discharging.
This will be your discharging. So it will be equal to how much? Potential across here A and B will be equal to total current I into your external resistance R. అంతే కదా, ఇక్కడ కూడా A, ఇక్కడ కూడా B కదా. దీనిలో కరెంట్ ఎంత పోతుంది? I. Ohms law. Potential across your A and B will be equal to I into R.
Yes, sir.
I can write here potential across your A and B will be equal to I value will be equal to how much better? I value is equals to your total EMF by your total resistance. I
Yes,
is
sir.
equals to your total EMF divided by total resistance.
Yes, sir.
Isn't it? That means I is equals to total EMF and on the E. Total resistance ante capital R plus small r. So I is equals to E divided by capital R plus small r into capital R. So this will be the potential across your A and B. Done better? Clear?
Yes, yes, sir.
So potential across your A and B will be equal to how much from here? I into R. I value is what better? Total EMF divided by total distance. So that I value is E by R. That value is substitute here right now. So that is your E
Yes,
by capital R plus small r into your capital R.
Yes, sir.
Okay now?
Yes, sir.
Next part.
సార్ ఇది బంద్ చేస్తారా?
ఏనా?
సార్ ఇది బంద్ చేస్తారా?
అర్థం కాలా?
ఇది బంద్ చేస్తారా అని అడుగుతాను.
You want me to close?
Yes, sir.
Yeah?
Yes, sir.
Sure. Next one. Combination of cells. Combination of your cells. Okay. First one is series combination. If cells are connected in series, how do you do the problem? Let's say this is a positive terminal, negative terminal, internal resistance of the battery. positive terminal, negative terminal, then internal resistance of the battery. Then again positive terminal, negative terminal, internal resistance of the battery. And this is some terminal B and this is some terminal A. Then EMF వచ్చేసి right now beta. Then EMF వచ్చేసి E1, then EMF వచ్చేసి E2, then EMF వచ్చేసి E3. And here it is your R1, this one is your R2 and this one is your R3. Okay beta. This total can be represented by one single cell and with this one like this. This is your A and this is your B. This will be represented by E equivalent and this will be represented by R equivalent. రాసుకోవచ్చా అన్ని సిరీస్ కాంబినేషన్ ఉన్నాయి కాబట్టి so what is right E equivalent all of them are in the same direction kabatti it will be your E1 plus E2 plus E3.
Yes sir.
Okay na? R equivalent will be equal to how much beta? R equivalent will be equal to your R1 plus R2 plus R3. Clear?
Yes sir.
ఒకవేళ ఇట్లా ఉంటేనా like say one positive negative here right now, then again positive and negative, and again right now here I am taking instead of positive some negative and there is an internal resistance. This is terminal B, this is your terminal A. Okay na? Then EMF వచ్చేసి E1, then EMF వచ్చేసి E2, then EMF వచ్చేసి E3. This is R1, this is R2, this one is R3. Now tell me how to write the E equivalent. So I can represent it by your one single cell right now like this. And this is a terminal A, this is your terminal B. This is your R effective and this will be your E effective. Tell me what will be the E effective beta? E effective will be equal to E1 plus E2, this one is minus of your E3. Then R effective will be equal to your R1 plus R2 plus R3. Done?
Yes sir.
So what is the difference beta in the above and below? Here we are having negative and negative connected. So that is the reason we got here negative. Here it is negative and positive as usually. So this is a positive terminal, this is a positive terminal, this is also a positive terminal. This is negative, this is negative, this is negative. So directly I can add them. So it is E equivalent is your E1 plus E2 plus of your E3. Whereas R equivalent will be equal to your R1 plus R2 plus of your R3.
Yes sir. Yes sir.
Next one. Parallel combination. Okay, that's it. Positive terminal, negative terminal, and internal resistance of the battery. Very important relations bit. And here negative terminal and positive terminal right now. Okay.
Yes sir.
This is a terminal B and this is your terminal A. Then EMF should ఇది E1 అనుకుందాం, ఇది R1, ఇది E2, ఇది R2. Positive is connected to negative and this positive is connected to this negative. Okay, this can be redrawn with one single cell of EMF, something like this. This is the terminal A, this is your terminal B, this is your E equivalent, this is your R equivalent.
Yes sir.
That?
Yes sir.
And how do you write the E equivalent? E equivalent will be equal to your E1 by R1 minus E2 by your R2 divided by your 1 by R1 plus 1 by R2. Okay, that means 1 by R equivalent will be equal to your 1 by your R1 plus 1 by your R2. So this will be your E equivalent. In formula derive చేసుకుంటా పోతుంటే ఇప్పుడు మనకు టైం అవుతుంది. So we are not going for derivation. So try to remember one positive, one negative, they are been connected. E1 by R1 minus E2 by R2 divided by 1 by R1 plus 1 by R2. And 1 by R equivalent ఎంత 1 by R1 plus 1 by R2. Clear?
Yes sir.
Clear? Any doubt in this one?
Clear sir.
చాలా ఇంపార్టెంట్ అన్న, దిస్ రియల్లీ వెరీ ఇంపార్టెంట్. సెల్స్ ఇన్ యువర్ సిరీస్ కాంబినేషన్ లో ఇఫ్ ఆల్ ఆఫ్ దెమ్ ఆర్ కనెక్టెడ్ ఇన్ ద సేమ్ కనెక్షన్ దెన్ ఈక్వివలెంట్ విల్ బి ఈక్వల్ టు యువర్ E1 ప్లస్ ఆఫ్ యువర్ E2 and R equivalent will be equal to your R1 plus of your R2. If some of them are connected in negative, then E equivalent is equals to your E1 plus E2 and another terminal negative property negative, and R equivalent will be as usually positive only. Even though they are connected in the wrong connection, negative negative, the internal resistance will not get affected. And they are connected in the parallel, one positive and one negative, then E equivalent is equals to your E1 R by divided by R1 plus minus E2 R2 divided by your 1 by R1 plus of your 1 by R2. Clear?
Yes,
positive
sir.
positive connect అయితే నాన్న
అప్పుడు ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ ఉండదు సార్.
అప్పుడు ఈ effective will become for me positive. Like say if this is a positive terminal like this here, Kirchhoff law apply చేసుకోవాలా. This one is positive, this one is negative. And this is a terminal B, and this is your terminal A. This is positive, negative, positive, negative. This is your R1, this is your R2, this is your E1, this one is your E2. That means E equivalent will be equal to your E1 by R1 plus of your E2 by your R2 divided by 1 by R1 plus 1 by R2. Okay, na?
Yes, sir.
Very important relation.
సార్ కానీ ఈ సెటప్లో ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ ఎట్లా అవుతుంది?
అంటే రెండిట్లో ఏదో ఒకటి పెద్దదై ఉండాలి కదా డామినేటింగ్.
రెండు సేమ్ ఉంటే
రెండు సేమ్ అయితే ఇంకా అవ్వదు. ఇది సేమ్ అయితే ఏమైపోతుంది రైట్ నౌ దెర్ ఇస్ నో ఫ్లో, కామన్ పొటెన్షియల్ అయిపోతుంది.
ఓకే.
కండిషన్ ఏమవ్వాలి ఇక్కడ E1 మస్ట్ బి గ్రేటర్ దాన్ E2,
నాట్ ఈక్వల్ టు E2.
క్లియర్?
Yes, sir.
Current electricity 3 questions నాన్న మెయిన్స్ లా.
అవును సార్, అందుకనే అడిగాను.
నెక్స్ట్ వన్ Kirchhoff laws. Kirchhoff laws. మనకు 2 laws ఉన్నాయి. One is known as Kirchhoff's voltage law and another one is known as Kirchhoff's current law. Okay, this is also called as of your loop law, and this is also called as of your junction rule. Okay, na? This is based upon law of conservation of your charges, and voltage law is based upon law of conservation of energy. Adiyadu sorry. This is also called as of your Kirchhoff second law.
Yes, sir.
Kirchhoff's second law. This one is your Kirchhoff's first law. Okay, na?
Yes, sir.
So if I'm talking about the first law గుర్తుందా ఏమన్నా నీకు? Sum of all the currents in a given junction must be equal to 0.
0, yes, sir.
Sum of your all the currents I net must be equal to 0. Okay, like say there is one resistance here, there is one resistance here, and this is a junction, and here there is some resistance. Okay, so there is some current I1 in this one, there is a current I2, this is a current I3, this is a resistance R3, this is a resistance R1, this is a resistance R2. And the flow of your current, if I'm taking right now, like say there is a flow of current in this one like this, and from here there is a flow of current like this, and from here there is a flow of current like this. Incoming will take positive, outgoing will take it as of your negative. Okay, so incoming is right now I1 minus of your I2 minus of your I3 is equals to 0. Okay, beta?
Yes, sir.
Current towards junction is positive. Away from junction is negative. Okay, na?
Yes, sir.
అంటే ఇది జంక్షన్, ఈ జంక్షన్ కూడా అప్రోచ్ అయ్యేది పాజిటివ్, లీవ్ అయితే నెగటివ్. క్లియర్?
Yes, sir.
Sure. Next one. What is the next law? Kirchhoff's voltage law. Kirchhoff's voltage law. I told you it is based upon what, beta? law of conservation of your energy. Ante kada?
Yes, sir.
Chudu. It is based upon law of conservation of your energy. First law is based on law of conservation of your charges.
Yes, sir.
Record అవుతుంది అది. Okay. KVL చెప్పు. KVL is what beta? Summation of your total potential
Yes, sir. Is 0
is 0.
for one
Means,
loop.
yeah, see this one. If there is a loop like this and there is some negative terminal, positive terminal, and here there is a battery, one positive, one negative, and there is some resistance for this one. And this is the given condition. And this is a positive terminal, this is negative terminal, this is negative, this is positive. This is some resistance R1 and this is some resistance R3. దీనికి internal resistance ఉంది ఇక్కడ. Right now this one is, say for example, R2. దీని EMF వచ్చేసి E1, దీని EMF వచ్చేసి your right now E2. Positive and negative, there is a flow of a current in this one, that is nothing but of your I. So the positive అయితే obvious గా you know that this side will also be positive, this side will be your negative. This side is also positive, this side is your negative. This one is positive. Again this one is positive and this one will be your negative. Clear as convention? This is your A, this is your B, this is your C, and this one is D. In the direction of your current, how do you write it better? See, if I'm taking in loop, closed loop is what beta? A, B, C, D, A. Oh, no?
Yes, sir.
A, B, C, D, A is a closed loop. Now apply the Kirchhoff law. The same direction right now. So if I'm going from your A to B, I'm moving in the direction of your current. Current is moving in the same direction beta. So in the same direction, if I'm taking positive I into your R1, some current is flowing in this one, kada I. Here also some current is flowing I. Here also some current is flowing I. Here also some current is flowing I. So like this. So I into your R1 plus of your I into your R2, same direction. Now battery is coming. Whatever first it comes with, I'm taking that one. So battery terminal is first negative. So it is minus of your E1. Then again in the same direction, plus of your I into your R3. Then again first negative terminal of your battery, minus of your E2 must be equal to 0. Done?
Yes, sir.
Isn't it? Same direction also name this positive.
Yes, sir.
You can even take negative beta. If you am taking negative, then if the cell should be taken wherever I'm ending, that will be my sign convention.
Yes, sir.
Okay, na చూడు ఇప్పుడు A to B వచ్చేటప్పుడు now I'm moving from in the direction of current. In the direction of current ఇక్కడ ఏం రాసుకున్నాను నేను positive I into R1. ఇక్కడ also in the direction of current I into R2. ఇట్లా వెళ్ళేటప్పుడు బ్యాటరీ వచ్చింది మధ్యలో whatever is the first terminal of the battery is touching you, that you should write here. Negative terminal is touching కాబట్టి minus E1.
Yes, sir.
Then B to C, nothing is there. Then from C to D, when I'm going, there is R3, I into R3 from positive, negative. And first, what is coming? Positive. That is the reason I have taken as plus of your I into R3. Then the battery is there. Then what is the first I'm coming encountering right now? Negative. So minus of E2. That will be
Yes,
equal to
sir.
0. What an idea?
Yes, sir.
Any doubt in this one?
No, sir.
Okay, na?
Yes, sir.
జేఈ మెయిన్స్ బుక్ తీసుకొని ఈరోజు సెల్స్ కిర్చాఫ్ లాస్ పైన ఏమైనా క్వశ్చన్స్ వస్తే ఒకసారి తీసి చేయను అన్న.
Okay, sir.
ఇజండి ఆల్మోస్ట్ 1 hour అవుతుంది. We'll try to do 1 or 2 questions. ఒకసారి నీకు నేను గ్రఫ్ గా చెప్పిస్తాను చూడు how the questions are being framed in the JEE mains. నీకు పంపించిన PYQs ఉన్నాయి చూడు. హలో వినిపిస్తుందా?
అవునవును సార్ అర్థమవుతుందా?
నో ప్రాబ్లం. నేను ఒక క్వశ్చన్ రాపిస్తాను.
ఓకే.
A cylindrical wire of radius 0.5 mm, and conductivity 5 into 10 to the power of 7, okay, Siemens per meter is subjected to an electric field of 10 millivolt per meter. The expected value of current in the wire. The expected value of current in the wire will be x cube pi m into a. The value of x is integer type question. చూడ సార్ క్వశ్చన్ చదువు ముందు ఏమేమి ఇచ్చాడు అసలు చెప్పు. cylindrical wire ఉంది. This is your cylindrical wire. Radius is given as 0.5 mm. Conductivity is given for me. Conductivity is represented by beta sigma, that is 5 into 10 to the power of 7, isn't it? And he has given me the electric field 10 millivolt per meter. The expected value of the current and I is equals to how much? Okay, we know current density beta, J is equals to sigma into E.
Yes, sir.
Current density means what beta? Current by your area is equals to conductivity into your electric field.
Yes, sir.
So I can write here right now, current is equals to, from this one, I is equals to sigma into A into electric field. Right, Cha?
Yes, sir.
So this is sigma, area will be equal to pi into R square into electric field E. Isn't it? So
yes,
that is
sir.
equals to your pi. Resistance is given how much for me beta? 5 mm kabatti 5 into 10 to the power of minus 4 whole square into electric field will be equal to how much beta? Sigma value is given for me. Sigma value is 5 into 10 to the power of 7 into E. E value is how much for me? 10 millivolts. Okay.
Yes, sir.
So this will be equal to your pi. 5 5s are 25 into 10 power minus 8 into 5 into 10 to the power of 7 into your 10. 10 power 7, 10 and 10 power 8, 10 power minus 8. Cancel.
Yes, sir. 25 pi.
25 5s are and 5 cube kada. 5 cube pi milliamperes.
Yes, sir.
This one is milliamperes.
Yes,
x cube and x value ఎంత వచ్చింది?
5. Sorry, sir. Question చెప్పింది.
Value of x అడుగుతున్నాడు.
5.
5. So x value is equals to 5. This is what.
Yes, sir.
Clear?
Yes, sir.
Sure. One more question. J mains question anadi. Next question. A current through a wire. A current through a wire depends on time as I is equals to your alpha naught into your t plus beta into your t square. Okay, na?
Yes, sir.
Where alpha naught value is 20 ampere per second and beta value is 8 ampere per second square. My question is, find the charge crossed through a section of the wire in 1.5 seconds. See the data what he has given me first. Current value is given for me. So what is the current? Current is as a function of time. I told you how to do it. Charge, first formula. Gurtunda? I'm audible better.
Yes, sir. Yes, sir.
Chudu. Charge, current as a function of time ఇచ్చినప్పుడు charge ఎలా calculate చేస్తాం? Q is equal to I into dt అంటే లిమిట్స్ తీసుకొని చేసుకోవడం.
Yes, sir.
Isn't it? Chudu this one. So given for me is what right now for me? current. So what is the value of current? I is equals to your alpha naught
Alpha
into
naught
t
into
plus
beta
beta
t
into t
square.
square. So I need the charge. So d cube is equals to integral of your alpha naught into t plus of your beta into t square into your dt. Limits will be from where to where, beta? In the wire. 0 to 1.5 seconds. And this is your integral of total charge. Integral of dq is nothing but q. That is equals to
Yes, sir.
alpha naught constant. Integral of t into dt is how much, beta? T square divided by 2 plus beta is out. Integral of t square into dt and nana. T cube divided by your 3.
Yes, sir.
Isn't it? What are the limits I can take right now? Limits are 0 to 1.5. Isn't it?
Yes, sir.
Now can you do the calculation? Everything is given for me in the problem. So charge q is equals to alpha naught divided by 2 into upper limit minus lower limit t la
Yes, sir.
1.5 whole square. అంతే కదా?
Yes, sir.
1.5 whole square ఎంత? 1.5 into 1.5.
Uh, 2.25.
2.25. ఇది 1.5 బదులు you will try to take some around 15 seconds. It will be easy for me.
225.
This limit will be 15 seconds. అంటే upper limit will be 15 square. 15 square అంటే
225.
plus this is your beta divided by ఎంత 3 into t cube again t cube t square t cube ఎంత 225 into 15 రాసుకోవచ్చా?
3375.
అంతే కదా?
Yes, sir.
Just simplify this one.
అది కూడా తీసుకోవచ్చు.
Alpha naught value ఇచ్చాడు కదా problem లో. Alpha
Yes,
naught
sir.
value is given, beta value. Alpha naught value is 20, beta value is 8. Just substitute that one. So alpha
Sir,
naught
minus lower limit చేయలేదు.
alpha naught value lower limit 0 నే కదా?
అవును, ఓకే ఓకే అవును.
This will be your 20 divided by your 2 into your 225 plus upper limit of the beta value ఎంత ఇచ్చాడు? 8. 8 divided by 3 into your 225 into your 15.
Yes, sir.
అవునా కదా? అంటే ఇది ఎంత అవుతుంది రైట్ నౌ? 2 1s are 2 10s are. ఇది 3 1s are 3 5s are 15. అంతేనా? 225 కామన్. 225
Yes, sir.
into your 5 into your 2. 5 into your ఇది ఎంత వస్తుంది రైట్ నౌ ఫర్ మీ? 2 into 1 plus 4. Can I write like this?
Yes, sir.
అర్థమైందా?
Yes, sir.
నో డౌట్.
No, sir.
అంటే ఇది ఎంత అయింది? 2250 into 5.
Yes, sir.
అంతేనా? అంటే 2250 into 5 అంటే 11250 degrees చార్జ్. కూలుమ్స్ కదా సార్? అంతేనా?
Yes, sir.
So that will be the answer.
Yes, sir. Understood.
Got it?
Yes, sir.
సో ఒకసారి కరెంట్ ఎలక్ట్రిసిటీ PYQs తీసుకొని సెల్స్ వరకు చేయి. టుమారో విల్ ట్రై టు డూ ద Kirchhoff law potentiometer and as well as of your series parallel combination of resistors.
Yes,
Okay.
sir.
Okay. అర్థమైందా?
రేపు కూడా పొద్దున
పొద్దున్నే తీసుకుందాం అన్న, ఎందుకంటే నాకు రెగ్యులర్ డేలో ఇట్స్ కంప్లీట్లీ ప్యాక్ ఫర్ మీ.